So as we proceed to do the next three problems, we will have to consider two things. What will the slope be? So if it's parallel, the slope will be identical. If it's perpendicular, we change the sign and reciprocate. And the second thing we must consider is we must find the y-intercept, or b, right? And so we have this y equals mx plus b slope-intercept form that we learned from algebra. We're going to use that. So here we go with part A. You'll note that there's an x value given and a y value given. We're asking for an equation of a line going to that point that's perpendicular to this one right here. So first, let's take care of the slope. If it is perpendicular, we're going to take this slope and flip it upside down. Reciprocate. It's called reciprocating. And then this is a positive 2 over 3. So we're going to change the sign and make it a negative 3 over 2. So that's the slope, and we're going to put that aside. We'll use that later. Next, we're going to go ahead and find that b value, that y-intercept. So we're going to start off with y is equal to mx plus b. And we're going to plug in the y and x value. So the x value is negative 12. The y value is a positive 6. And we're going to simplify this. As we do, it's very important that you recognize this is a multiplication. So don't complicate the problem and make this a minus. This is a multiplication. And also be careful with how you write and take your notes. This is a lowercase b. This is a number 6. So be careful with that. We do know what the slope is. So let's plug that in. And for those of you that are tripping about fractions because you can't quote-unquote do them, we'll put this over 1. And there's a couple ways to approach this. We can multiply across. So for example, we get negative 12 times negative 3 is positive 36. 1 times 2 is 2. And if you divide those, you get 18. Or if you wanted to kind of cancel things out, if you're that good, you can cancel this out for a 1, cancel this out for a 6. And then negative 6 times negative 3 is a positive 18. Now we want to get the b by itself. So we subtract 18 from both sides. That becomes a negative 12. So b is negative 12. Okay, that's our y-intercept. So b is negative 12. So what happens now is I have the slope. This is m. I have the b is negative 12. So recall that the formula was y is equal to mx plus b. But we said that the slope is going to be negative 3 over 2. And we said that the b value is going to be negative 12. So this is the formula of an equation that goes through this point that is perpendicular to this line. So that was for a perpendicular line. Here's for a parallel line. Again, these are x and y values. We do two things. We first find the slope that will be parallel to this line, but the slope will be the same as the other line slope. So there's no math to do. It's just negative 3. We only reciprocate and change the sign if we want the slope for a perpendicular line. This is parallel, so we just copy and paste. So we're done with the slope. Step 2, let's find that b value. We'll begin with the y-intercept form, the slope-intercept form. We plug in the correct value, so y is negative 1. The slope is negative 3. And the x value is negative 2. We can go ahead and simplify this. We're doing this to find the b value. So negative 3 times negative 2 is a positive 6. Don't confuse those. This is a b. That's a 6. We subtract 6 from both sides. We get a negative 7 is equal to b. So we have the b value, and we have the slope. So let's go ahead and plug those in. The new slope is going to be -3, and the b value is a -7. Or in other words, we get this equation right here. Note that the only difference with this problem compared to part A was the slope. This was for a parallel line, so we pretty much just copied and pasted this slope into our new equation. It's pretty much half of the work done for you. Pretty smooth. You're going to have to find that b value always by setting up this slope-intercept form, plugging in the three values that you have, solving for b, and then putting that back respectively. For this problem, we recognize this is x and this is y. This is the line that we're looking to be perpendicular to. So perpendicular means we're going to reciprocate the slope and change the sign. So right now, you might be asking, what is a slope? It might help you if you actually rewrote this as a 1 times x. It's not a 0. There's a 1 right there, a coefficient of 1. And if you're thinking, well, Mr. Over, there's no fraction, then go ahead and make one, 1 over 1. Okay, so take that slope and reciprocate it. Flip it upside down. So that's going to be the 1's going to go up there, and then the 1's going to go down here. And currently it's a positive, so I'm going to make it a negative. Now, we don't have to be silly about it because what's -1 over 1? -1. So the slope for our perpendicular line is going to be -1. Let's go ahead and take care of the b value. We go ahead and use the slope-intercept form. I'm going to put parentheses here. We are solving for b. Note that the slope that we're going to use is not the original slope. We're going to use the new slope. So in parts A and part B, we always used the new slope. If you're thinking, well, Mr. Over, in part B, we use the same slope as the original, that's because parallel lines have the same slopes. But if you want an always rule, we always use the slope of the new equation. So the new slope. So we're using -1 for the m. X is going to be 0. Y is going to be -1. This is a b. So what we have here is -1 times 0, right? This is a multiplication, not a minus. This is a multiplication. So anything times 0 is going to be 0. So b is -1. It's kind of an anticlimactic problem. So we have b is -1 and the slope is -1. Let's go ahead and set up our equation for the new, right? This is the new line. This is the line that's perpendicular to the original one given. So we set up the y is equal to mx plus b. We plug in the values we got. So the new slope we got, -1, goes in here. And the b value goes in here. And let's clean this up a bit. A plus and a minus gives me a negative. And if you want to leave this as -1x, you can. However, on assignments, you're not going to see this 1 there. So that's why I'm writing that without the 1. Of course, you're invited to graph these by hand, which nobody has time for. Or if you want to use Desmos, you could graph these two lines, right? You could graph the original line and then graph the new line. And they should be perpendicular. In other words, they should be doing something like this, right? Forming an X. And if they are, good, you got it right. If you're looking at part B and they're supposed to be parallel, they should look something like this. For your summary, how is the given point used to find the equation of the above lines?